Hey folks, how's it going everyone? My name is Peter Hansens. You're at the online data engineering meetup. We're all back in lockdowns or about to be back in lockdowns from what we can tell, although Melbourne are pretty close to exiting out of one, I'm pretty sure. So yeah, it's fun times at the moment, but really glad we can keep meeting together online at least. We were scheduled to have an in-person meetup yesterday in Sydney, and we were hopeful of having an in-person meetup in Melbourne actually sometime or other this week or so. But anyway, we're doing it all together online, which is really cool. We get two awesome speakers, one from Melbourne, one from Sydney tonight. So that's really cool. So we've got a really good lineup. We've got Dean Nguyen, CEO and co-founder of a local data engineering startup called KADA that specialize in data lineage and metadata. They've built a really cool tool around that. And then we've got Mathew Taylor, the lead data engineer from ELiiza. I think they're sort of really do some great work in the machine learning space and the like, but they've got a really cool data engineering practice there. So, and Matt's going to take us through data sheds and data cathedrals. In other words, stop focusing on the data and start focusing on the users, which I think having a bit of a product focus to data sounds like a really cool topic. But before we dive into that, we've got Ingrid Nzola, one of our committee members for DataEng Bytes, joining us tonight. She's going to take us through what's happening in the awesome world of DataEng Bytes. So that sounds pretty cool. So I'll get you to share your screen, which is up right now. Take it away, Ingrid.
Thank you, Peter. Hi, everybody. It's good to have you here. I just wanted, before we start, remind you all that we have an awesome conference coming up on August 26 and 27 by DataEng Bytes. And as you can see, we are still open for submissions. So if you want to talk about real-world experience around topics like data address, data for machine learning, data in motion, and data you can trust, please send your application, your submission, and we are very keen to have a mix of speakers this year about all the experiences. We are a global community. If you are attending in person or online, it's going to be a combined conference, so please get your tickets as soon as you can. We are aiming for an in-person conference in Sydney and Melbourne. Melbourne venue will be announced, but let's be reassured that we are going to be COVID safe, and if we have restrictions or lockdown, the tickets are completely refundable. So that's good. So feel free to buy your tickets, and if COVID forces to have a full virtual conference, we will be there. We will make sure that you have your money back. And a big shout out to our amazing sponsors. As you see on the screen, Snowflake, Fivetran, Databricks, dbt, Versor, Imply, Yao, and Cloud Shuttle that make possible this conference. I think it's going to be great. So yes, join as soon as you can. You're in mute, Peter.
I was on mute, sorry. Thanks so much, Ingrid, for all the efforts. I know firsthand it's a lot of work putting these conferences together, but I think it's also a lot of fun, right? Awesome. Well, thanks so much, and I'm sure we'll be hearing from you soon. Thanks so much, Ingrid.
No, Peter.
Thank you. All right, so without further ado, I'd like to welcome to the virtual floor Dean Nguyen. He has got a really cool background. He's come from being the chief data product owner at Macquarie Bank, probably was in that role before data product owners were even a thing, I guess. So I think he's probably got a lot of wisdom that he can impart on us today. So I'm super excited for this talk. I think it's really great to hear from entrepreneurs here in Sydney doing lots of cool stuff in the data engineering space. So without further ado, take it away, Dean.
Great, thanks, Peter. All right, hi team, thanks for tuning in this evening. It's a shame we couldn't do this in person. So as Peter mentioned, my name is Dean Nguyen. I'm the co-founder of an Australian data startup called KADA. And the talk I'm going to do tonight is really about the emergence of data as a product and how you can shift over to it. So before I jump in, let me quickly introduce you to KADA. We're a data product analytics platform. Think of it like Splunk for your data and analytics ecosystem. It works by analyzing metadata and logs from your data platforms to map out your data ecosystem and to track how data is being used over time. And the results of that is really to allow data producers to see how their data products are being used and to give data consumers a personalized data experience to improve adoption and use. So we started out because from our experience, getting value from data is really hard. And what makes it even harder is when you can't measure whether you're getting value or not. Part of our origin story started when we shifted our data teams to a product model at Macquarie Bank. And parts of that story and what we learned there and how we built our product to solve for those problems is what I want to talk to you about tonight. So what am I going to speak to you about? The first part is to talk about the product principles you need to consider for your data. The second is talk about some of the challenges that you may encounter when you take a product approach for data. And the third is to talk about some steps that you can do to improve the success as you shift over to a data as a product model. So one of the first questions you have to ask yourself when you are thinking about shifting to a data as a product model is what can be a data product? I think of this as something that can change from organization to organization. But in my experience, the atomic product, the smallest product is essentially a data set or a feature set. The most complicated products can be at the other end of the scale, something like a mobile app or a combination of multiple pipelines, files, dashboards, and APIs. Regardless of how you decide what is a data product, there are three principles that I think you should keep in mind. The first is that a data product has a user. It may sound strange, but products exist because someone somewhere needs it. When I was in the data product team, often the focus, especially with our engineers, was on the technical challenges rather than the user needs. It takes some time and consistent work to put the user at the center when you're discussing features in a data product team. Before taking a product approach, we focused on making sure data sets and reports were available. That was the objective. If the data was available, then our job was done. When we took a product approach, though, we started to ask ourselves new kind of questions like, what is the first experience a data user is going to have? What is that going to be like? Have we designed it to be easy and intuitive? How were they going to get value quickly? This principle of putting the user at the center really changed the way we thought about our products and ultimately what we actually delivered. The second principle is to consider that products go through a life cycle. They get launched, used, and then they die. And if you're lucky, your data products keep growing and growing, or they reach a level of stability over a long period of time. But if your data products are bad, they can go from launch to dead in a few days. And why does this happen? Because the way we design data products needs to match the rate at which the product is expected to go through the life cycle. Don't spend a lot of time engineering a very complex solution when the product is expected to only have a lifespan of a few days. And the final principle is that each data product needs to have a North Star metric, something that helps to define if the product is working or not, if the product is delivering value or not. Something like active users over a period of time, total usage over time, percentage of users engaged in a cohort, time between runs. Whatever it is, it should be a good indicator of where in the life cycle the product is and what actions you need to be taking. Now that you know of a few of the principles, what happens when you start applying them to your data products? In my experience, there's a few big problems that become apparent very quickly. The first is that depending on how you define a data product, you can have a lot of them. If your atomic data product is a data set or a report, you can have thousands of data products for even a small company. I think this is why data products are a very different beast compared to mobile apps or a website. The scale, the pace at which they can be built, the ease of which they can be duplicated, the scale makes data product management harder. The second challenge is that if you can actually measure the life cycle of your data products, you will find that they die fairly quickly. From our work analyzing millions of data products, 97% were dead within 90 days. It's a pretty high casualty rate. Just as alarming was that the majority of these data products were still being maintained, being run, being generated, even when they were generating no value. It's a huge waste of resources and time. And if you're running these in the cloud, you're basically flushing money down the drain. And the last challenge I want to talk about is that data products are generally not designed with user experience in mind. That's why you get these kinds of issues from your users, issues about access, about understanding and trust. How many times have you heard someone say, I didn't even know that report existed? Part of this is because the user experience is not something that data teams generally think about. But the data experience has a huge effect on the value and longevity of your data products. So if the scale, longevity, user experience is a big challenge for your data products, what can you do about them? Well, let me take you through 5 steps you can take to improve how you design, build, and ultimately deliver your data products. Now, I'll be showing you how we do this in our platform, which leverages metadata and logging to address these challenges at scale. But you can take the ideas and implement them in your own way. The first thing you can do is to define a metric for all of your data products. For data sets, you can use something like usage over time. It's a very simple way to see if there are users that are actually using it. You can plot this against the cost of manufacturing and maintaining that data set. It basically gives you a way to calculate return on investment. Here's an example of a pretty healthy transaction table. It's being loaded and used every day. One insight, though, that this gives us is to have a look at optimizing how we load the data on weekends, since the usage is pretty much Monday to Friday. And once you've set a metric, you can actually help guide you through the life cycle to understand when a product should be retired. Take this report, for example. It's a classic case of a report that had been used a few times and then forgotten. It's never really taken off. Once the product is dead, you can archive it. You can get rid of it. You can remove it so that it doesn't clutter up your data ecosystem. And if you're processing it on the cloud or in Snowflake, for example, make sure you turn off the compute. Otherwise, you're spending a lot of money for nothing. We all have those stories where someone blew through a month budget on something that nobody was using. The second thing you should consider is, how do you engage your users through the life cycle of a data product? And the key points I want to talk about is essentially the launch of the data product, as well as when changes happen. Now, you can do this manually, but it takes a lot of effort, especially if you have a lot of data products. Think about how you can automate those engagement points. One thing our platform does is it creates a personalized experience for every person based on what they use. This means that you can engage people at a very deep level about, say, a new product being launched, or when changes happen to existing products, or even actions like governance classifications, for example, that are often dark to most people. One of the most exciting things is the ability to engage the people at the right time, like when they use a data set for the first time. The third thing that you should also consider is, how do you create a feedback loop for your data products? One of the things that we do is we capture feedback, opinions, confirmations from users at different parts of the product lifecycle to give product owners the insight on how to improve their data product. Now, if you can't do this automatically, then at least try to consider doing it periodically, so that you've got some understanding over the qualitative value that your products are performing at. One cool thing is that you can actually use these feedback loops to actually turn your users into a feature of the product as well. One way that we do that, for example, is we use the usage down to an individual and team level to actually improve our search and personalization engines. These are some of the ideas that you can use for your own data products. An easy way to think about how to make your data products more useful is to consider, how do your users actually know how to use the product? It sounds stupid, but I haven't seen a lot of organizations that actually make data easy to use. They don't put a lot of effort into how do they scale their data knowledge. I actually think of data knowledge as a growth hack for your data products. If you can make it easy for your users to understand how to use the data, or how to use the product, how to query it, how to get some sample code to run it, how to understand how data joins together, or how data feeds into other data. All of these things help to elevate the data literacy of your organization, and ultimately leads to your data products having a lot more stickiness. Now, there's a lot of metadata that your data products produce, and you can use that to make the scaling of data knowledge easier. The thing to consider, though, is how often it's updated, how fresh it is, and how do you get your users to trust it. And the very last thing I want to touch on is make the data experience easy. One of the key things, the biggest road bumps that we typically see is about making access to your data products easier. Now, I don't mean easy as in remove all controls, but easy as in the process to get access is known, understood, and ideally really fast. One of the coolest approaches I've seen is that one organization actually automates the whole process in Slack. When somebody wants data, the owner of that data gets a message to approve in Slack, and once it's approved, it goes all the way through to the automated provisioning. Very cool way of how the data experience was significantly improved from the very manual way that it was done in the past. So that's the end of my brief chat about data products, some of the challenges that you'll face, and some of the things you can do to make your products more successful. I appreciate your attention. It's been great to be able to have the opportunity to have this chat. And if you'd like to have a chat about the topic or to see more about our product, reach out on the Slack channel or via email. Back to you, Peter. think you're on mute, Peter.
There you go. Probably just the way everyone wants me. You did a really awesome job keeping it nice and concise, but super informative. I really got a lot out of it. Great topic, just in terms of, I guess, just usage metrics of tables and things like that in the warehouse. I know, there is a little bit of that data lying around in the information schemas and different things that are getting collected and stuff like that, but often not very well kept track of. And then even just this concept of having tables and schemas within a warehouse, having data owners that you can sort of request permission to access from and things like that. So lots of really cool topics that you've sort of brought to our attention today. And I think it's probably a really cool point of discussion that hopefully drives more and more folks to talk a bit more about it. And sort of one question that I've got for you as a sort of a data engineering startup CEO, how are you finding the experience sort of building out a data engineering product and things like that?
It's certainly a very different experience from working in a corporate. One of the things is that we sell our product primarily to sort of large organizations. And generally it's because the larger the organization, the bigger the challenges are in terms of understanding how data is being used. In saying that, we actually have a few of the sort of the scale up or smaller organizations using it because they still face those challenges as well. But the challenge of building our data product has generally been around scale. Because if you imagine trying to calculate these kind of metrics for every single, say, table or column in a large organization's data ecosystem, you're talking about millions and millions of data points, potential data products to capture, but then you have to times up by the time series that we actually capture that data over as well, which can be years. So when you look at that, the engineering complexity is actually very, very difficult. The great thing is we've got a great team that can do that. But it's just one of those things that, as a startup, one of the biggest challenges is being able to generate that kind of data to be able to simulate what real life would be like, but then engineering our solutions around it as well. Very complicated, but very exciting.
Yeah, do you need to sort of sometimes kind of evaluate what you should go after and what you should just kind of leave behind? Because I guess being part of a startup is about sort of being first to market and just being really nimble, and or do you find that the capability that you've got in-house kind of enables you to sort of do it all?
So I think there's definitely you have to define what that sort of North Star metric is, and we kind of dog food our own kind of principles as well. So how do we define our metrics for our product that ultimately is indicating that it's being used in a way that is successful? And I think for us, we use that to guide our feature development. We use that. Put the user at the center of our own product to understand how they're going to use it and get the most out of it. I think that's why, whilst data engineering products are very exciting, not a lot of them have actually managed to become very sticky. And that's because I think they focus very much on the technical challenge, but not necessarily on how the users are going to adopt them, pick them up, and maintain them over time. So that's kind of the bit that always balances between how we design the product from a front end versus the technical challenges that happen on the back end.
Yeah, that probably flows pretty well into one of the questions from one of our viewers, P Chen. They've asked, how will or can data products flow smoothly across organizations in future, in your view?
I think the thing with data products in general is once you can define what the metric is that makes a product successful, what you typically find that as you build out your data ecosystem and the products, there's actually only a handful of generally value generating data products. I think the rest is kind of noise that happens over time, and part of that is the ease of which data products can be produced. Like you can build a report, you can copy the report, make one change, and technically it's another thing you have to maintain. But when you can actually define what data products are useful, I think there's only really a handful that you actually have to maintain consistently over time. And it kind of matches the maturity of the organization as it improves. In terms of how those products will expand as across an organization, I think what's really interesting is when you can define the products in the context of a domain. So, for example, what kind of products fit into what domain and what products will flow across domains. And how you actually manage cross-domain products is usually the biggest challenge when it comes to scaling up a data product so that it's valuable beyond just a small set of users.
Very cool. Well, thank you so much for the insights, Dean. Really, really great to have you on tonight. And thanks for making the time. I know you really wanted to do your presentation in person, but great. We'll have to catch up in person at a later date. But thanks once again.
Absolutely. Thanks, everyone.
Cheers. Awesome. Well, up next we have Mathew Taylor. Matt or Matthew, is it?
Matt, definitely Matt.
Cool. So you're a lead data engineer at ELiiza. ELiiza's a kind of like a machine learning consultancy, if you will. Is that kind of roughly? I'm sure you've got a much fancier explanation.
Yeah, I've got a bump slide which I'll hasten through just for the just to please my CEO. But yeah, once I get started, I'll give a quick intro.
Yeah, so you've done a lot of work for like online advertising companies like Google, AOL, and Unruly. So all of that clickbait and stuff like that. You're the man who we need to
to point the finger. Yeah, unfortunately.
Yeah. No, fair enough. So you're going to be talking about data enablement, building data platforms and the like, a bit more discussion around data products and things like that. I think it's a really cool line of conversation. So I'm very much looking forward to your talk. So I might just leave you to it.
Brilliant. Cool. Thanks, Peter. Thanks, Dean. That was a brilliant, really interesting product you've got there, which I'm going to delve into. So hi, everyone. My name's Matt Taylor. So yeah, as Peter said, I work for ELiiza. So just to give the quick introduction, yeah, I'm a lead data engineer at ELiiza. And ELiiza is a data science, machine learning, and data engineering consultancy in Melbourne and Sydney. And we help clients develop data strategies, data platforms, and pipelines, and design and build complex machine learning systems. So that's the advertising bit out of the way. So what I want to talk about today is data cathedrals and data sheds. So really kind of what is the purpose of this talk? So one thing I love about data engineering, especially over the last probably 4 or 5 years, is basically the amount of buzzwords which crop up and are in circulation. So nowadays, all we kind of hear about is data enablement, building data platforms, creating data democracies, and making data-driven decisions. So we've got these beautiful buzzwords or phrases which are always kind of bandied around by companies and executives. And whilst this is music to my ears, because I love data, I love building things with data. For all the buzzwordage, this isn't really happening. Like we're not actually succeeding very often in building these data democracies and creating real data enablement. And you don't have to kind of believe what I say. I've got shocking stats, which obviously I've pulled from the internet, so they're probably taken them with a pinch of salt. But there is a worrying amount of these kind of stats over different publications, and these are from kind of Gartner, Harvard Business Review, and New Vantage partners. And if you look at them, it's quite worrying, even if they are kind of bumped up or designed to shock. And we've got 85% of data transformation projects fail in their desired outcome with time and cost and impact. 77% of executives report that business adoption of big data is a major challenge. And this is from a recent report. Only 24% have forged a data culture or data-driven organization. Now, I know it kind of seems quite extreme, but imagine if we were talking about retailers with regards to online sales or selling through their website, so Miles or David Jones. Imagine if we were sitting here saying, well, only 25% of retailers have managed to make significant online sales. We'd really be thinking something was quite wrong. And then another kind of stat is that 93% of respondents to, I think it's Harvard Business Review, identified people and process issues as the obstacle to this. So it's not that the technology is not there. And if we look at data engineering, there's loads of technology. It's getting pretty advanced and mature. And it's not that the data isn't there, because we know it is. It's just it's not being used or accessed in the best way. So why is this happening? So in the years that I've been working in data and building data platforms and building horrendous online advertising platforms with data, I've kind of noticed two anti-patterns which keep occurring over the few years. And these are kind of what I've called data sheds and data cathedrals. So what I want to do in this talk is to kind of delve into what are these data sheds and data cathedrals, and why are they preventing us in succeeding in creating our kind of data buzzwords from coming true when we build data platforms. So here's some sheds which I've kind of grabbed from online, and obviously, hopefully, most of you know what a shed is. But if we look at these sheds, they've all got similarities. They're all sheds. They've got a shedy quality, and we'd be able to point out and say each one was a shed. But they've all been built in their own special way for their particular owners or kind of their users' needs. And this is something that keep happening. I keep seeing in data, kind of data platforms or data enablement when companies kind of go down this route. So some people call these data silos. And I actually think this is worse, because quite often it's not the starting position where our data is siloed. It actually is a kind of a process when companies are building data platforms or trying to kind of get data out to the users. They go down this path where they start creating these data silos or data sheds. And so this is where the data and the data pipelines are pretty tightly bound to specific use cases. So typically, a problem is found which can be solved by data, and then they're solved kind of one at a time. So we kind of start off on a data journey, we find a problem, we build a pipeline, we get the data, we push it to the users, problem solved, and we find the next one. And so data surfacing, processing, and use is really focused to solving that particular problem rather than kind of any problem in the whole. And typically, you see this occurring quite often in kind of companies where they're making their first venture into data. So they haven't typically got any kind of data beyond their normal database, but they've kind of grown to a scale where they need to start kind of getting a bit more analytics or a bit more reporting in there. And so quite often they're kind of dipping the toe in the water. And what that means is they kind of scope down quite far. But the problem is once they've scoped down and you've kind of proved that it works, it's hard to scope back up again. So you kind of get into this kind of feature death march where you keep building for a feature, then a new feature, then a new feature. Another way this kind of happens is quite often when you need visibility or proof on return of investment. And so, if you want to build a data platform and you want to build kind of, one which is can satisfy all kind of data needs, it's really hard to show that to someone high up who's financing it. So quite often the only way you can kind of get the funding or show that you've got a return on investment is to kind of build these end-to-end solutions one at a time to kind of prove that things are being done. And the third way this happens, I find, is that quite often, and this happens in quite large companies as well, is where they've moved to quite a strict kind of agile or scrum-driven development. And so any kind of type of development is really driven by user stories. And what I find is that if you don't have like a data product owner or a product owner who kind of has worked within data, the user stories are often just under the end user. So they kind of, as a user, I want to access X data or view this data in a dashboard. The problem is that that really leaves out all the other users that might be touching that data. So as a data engineer, I am a user of a data platform, of a data pipeline, and I have certain requirements around that data platform. But quite often it's hard to bubble up my requirements into user stories. They're kind of ignored because they're more technical rather than user driven. So you can kind of spot this anti-pattern happening in companies. And typically it goes kind of like this. So you have a company and they say, we need a data strategy. They find a problem which can be solved by data. They get some data engineers in, they solve the problem, and they go back to go to two, find another problem which can be solved by data, and so on. And so, as I said before, you kind of get into this feature death march because each solution tends to only solve one problem for a particular user. And then the use of data comes bottlenecked around the capacity of the data engineering team. So rather than enabling users to solve their own problems with data, you're just kind of spoon feeding the solutions to the users. And so, yeah, we're really not allowing this whole kind of data enablement, data democracy from happening. As I said before, stories and deliveries tend to be around the end user focus, so kind of other needs are ignored. And the final problem with this is you kind of end up with this data is everywhere. Like everyone has their own small shed of data, and it's really hard to work out what's going on, what data is where. You lose your data lineage, and it's really hard to get that data governance. And the problem with that is, come auditing time, especially if you're in a financial company, there's going to be real trouble because there'll be questions on where's your data and who has access to it and what happens to it, and it's really hard to do this. Okay, I'm actually going to ask a question. So, does your data engineering team get tied up in a constant cycle of feature development? Yes, this often happens. A previous company I had were really based around the kind of lean agile methodology, which worked well for product development, but it meant on the data engineering side, on the reporting side, we were tied into this 3-month feature. And so as the company grew and the amount of data grew, we were never kind of given the time to actually sit down and be like, okay, how can we cope with this huge amounts of data? How can we make it better? It was always just kind of adding features on top of other features and building this really shaky structure. So yeah, one real problem with this is this kind of cycle of feature development rather than being able to actually build solid data foundations. So that's kind of one problem I see is data sheds. The flip side of this is what I'm calling data cathedrals, and this is kind of the exact opposite of a data shed. So here's a picture of a cathedral. If hopefully you've seen cathedrals before, but this is a Sagrada Familia in Barcelona, and it's been under construction since 1882. Apparently, it's going to be finished in 2026, but who knows? But this is kind of probably quite familiar to a few people. And so the problem with data cathedrals is when you build this, you kind of bunch all users into one giant user case and build a huge, all-encompassing, build it and they will come data transformation project. And this is quite often kind of, if we look back in the history of data engineering, this is quite often what kind of the early data lakes became. It's kind of like, let's put all the data in there and it'll be available for everyone and everyone can use it and it'll work out completely fine. But quite often this doesn't happen. And the reason these kind of data cathedrals get built is because, one, we're ignoring the users, and we're actually building these data platforms from a purely technical standpoint. So we're kind of basically picking the best of patterns and really kind of investing huge amounts of time and effort to try and solve all the problems in one go. And typically this is driven by quite often the isolation of the data team from any product teams. And so this is kind of quite similar, hopefully, for what Dean was talking about, is when you kind of have a data team within a company and they are just by themselves and they don't reach out to any kind of product teams. They don't really care what the data is getting used for. They just want to build cool stuff with their data. Quite often this is driven by large budgets and actually big egos. And I don't mean big egos in a kind of bad sense, but in terms of, I'm a data engineer, if someone gave me a huge amount of cash and said, go and build something cool, why wouldn't you run with it and have a bit of fun and try and really build something awesome? But the problem with that is you can go too far and not actually really deliver. And again, yeah, the data strategy, quite often with data strategy, is really built around technical requirements rather than kind of user requirements. And so the kind of path that gets followed to build a data cathedral is you start off where we need a data strategy, and then you go down this route of picking the latest, greatest, coolest technology and design buzzwords. You design this beautiful solution, you build a solution, you keep building the solution, and you go to 4, and you basically build and keep building and build and keep building. And so usually these end up being this kind of massive budget-breaking, deadline-smashing kind of monoliths, which no one can actually really kind of navigate or use. Like, they're very technical, and as we know, a lot of data users aren't technical. So it's kind of missing that kind of, the barriers to entry for using these kind of data solutions are too high. And so the data becomes bottlenecked, not around the data engineers, but actually around the skills and requirements of the data users. So if they haven't got the skills to actually access that data, they're kind of stuck. And so rather than enabling users to solve problems, it actually creates these quite large barriers to entry. And then a kind of a side problem from this is that the long build time means that data sheds are popping up all over the place. If you're not helping users kind of solve problems, they're going to try and solve them themselves. And so you kind of get these kind of side or ghost systems, which users kind of build just to get through and get the data they want and get the kind of solutions they need whilst you're building these kind of huge architectural cathedrals. So kind of what can we do? How can we stop these two sides happening? So if we look at the amount of data kind of users or data users or kind of people in a company which kind of need to use data or touch data, it's actually pretty broad. We've got executives, customers, business analysts, HR, sales, ML engineers. Like, there's loads of different users. And so really there's too many users to create these individual solutions for, but also there's too many to treat as kind of an amorphous blob of users. And so that's why I see these data sheds and data cathedrals kind of failing, because either we're treating each of these use cases or users separately, or we're just treating them as a whole. So what we can do is we can actually, rather than seeing them as individual users or one big whole, we can actually divide them into kind of user types. And so we've kind of come up with these 3 kind of profiles on users. And so we've got data enablers, data operators and analyzers, and data readers. So with data enablers, the data is the daily work. So they're the kind of users who've got really strong technical skills and knowledge about data. Not necessarily the data they're kind of touching, but just about data in general. They're used to handle data wrangling. They're used to kind of using the source or raw data. And really their concerns are with kind of sourcing, processing, moving data, and making it usable for other teams. And also kind of creating platforms and frameworks for other teams to use with data. So the key requirements for them is kind of access to data and being able to use a wide range of tools to carry out their work. And so the kind of roles we look at when we're talking about data enablers, we're really looking at kind of data engineers and then potentially ML engineers, depending on kind of what level and what they're actually doing. The data they use, is the raw data, and so what we say they've got a kind of a high trust or maturity with data. So they're used to dealing with data with low accuracy, multiple sources of truth. There's no filtering or deduping on data, so there might be fraudulent or duplicate data kind of around. But they're used to that kind of stuff, and they can be relied on and trusted to access this kind of data. And so the kind of architecture, technology, and tools for these kind of users is we're really looking at kind of a data lake or data lakehouse kind of style. So data stored on S3 or GCS, so it's kind of file format in its original format. So that might be like Avro or fixed width or Parquet, depending on what's coming in. The tools they're kind of using to process and kind of play with this data are the kind of large distributed processing frameworks, so kind of Spark or Hive, kind of using EMR or Glue or Dataproc, or even to say BigQuery and Snowflake. So kind of keeping that data processing and data storage separate. And also data enablers, they really want to control of the data is important, or data management. So they're looking at kind of data governance tools and lineage tools, and also kind of building out these kind of abstractions for frameworks and tools for other teams to use. The next kind of group is our data operators and analyzers. So these are data users who data is an input to their daily work. So it's not, they don't particularly want to know about how to manipulate or kind of source data or play with data, but they want to be using data to drive or to help in their daily work. So they've got domain knowledge about the data. And so the kind of data operators and analyzers we're kind of talking about, we're talking about business analysts, data analysts, software engineers, and ML engineers. So really they're getting this data and they're using it to build features or to drive applications or analytics. So they have a kind of medium trust or maturity with data. They understand there's limitations. They know that they can get incorrect results from kind of joining different sources of data. But part of their job is to get these kind of data inputs and use and manipulate it with software engineering languages or SQL or different tools to kind of join data from different sources to kind of to drive applications and to push this data onto the next layer. So the data they want to kind of be accessing is kind of processed and cataloged and schemaed. And they really want kind of defined formats and set tech choices or interfaces or tools to use. So, they kind of want they need their data to be given to them in a certain format, and they want to use certain tools to process the data. They don't want a lot of choice around that. But they do need a high level accuracy. So this data does need to be processed. So because the data needs to be processed and joined with other data. And so for this group, the kind of architecture, technology and tools, we're really looking more around about kind of more data mesh or data APIs and or data warehouses, depending on their use cases. So for like data operators who are kind of using data to drive applications and build features, we're looking at kind of more like Kafka, Beam, Python and Java, and kind of application-specific storage and processing. On the data analyzer side, we're kind of now looking more like data warehousing solutions, so Snowflake, BigQuery, Redshift, and they're most likely going to be using SQL or systems like dbt to process and push on this data. And then the final group is our data readers. So they're using data to drive decisions in their daily work. So they've got business knowledge about data. So they don't really care where the data came from. They don't really kind of care how the data is formatted. That should be all abstracted away. What they're interested in is getting a view of the data so they can make decisions. So they're using data through features or to get specific answers to specific questions. So the kind of people we're looking at in this group are kind of executives or external customers, finance, HR. So really kind of non-technical members of a company or kind of or customers or clients of that company. In terms of data, we give them a low trust or maturity rating. So that means they can't really be trusted with data. And what that means is for example, imagine if you're checking your bank balance. Like, you don't want any discrepancies there, and you don't consider there will be any discrepancies. That when your bank balance comes up, that should be what it is. So there can't be any inaccuracy. So there has to be a high level accuracy. All the fraud and duplication has to be removed. There needs to be strong SLAs in terms of that delivery or querying that data. For example, again, if you go to your bank account and you query your bank balance, you don't want it to be take an hour to return the answer, or you don't want it to be kind of X days old. It has to be accurate and timely. And so the data is provided, it needs to be highly usable and ready for consumption by users. And so the kind of technology and tools that these users kind of need are really more kind of internally they're access to, say, reporting systems. So, for example, like Tableau, Looker, or Power BI. And then externally through applications, so like mobile applications or web UIs or even chatbots. So in terms of abstraction, they're really abstracted away from the data itself. They're more viewing the data or reading the data through these systems. And so we can get these kind of three kind of user groups. And we can see how we need to kind of layer our data platforms or our data solutions. So rather than having this kind of data cathedral where it's one solution fits all, or where we kind of pick individual kind of users and problems to fix, we can actually start laying our kind of platforms to solve or to provide the data and the tools at the right level for the users. So the data and access and tools are specific to the layer with which the user type operates. And then between each layer, we should have kind of interfaces which abstract the user in that layer from the knowledge needed in the layer below. So if we look at kind of, it's quite busy diagram. At the bottom, we've got our data enablers. So they're the data engineers and ML engineers. So again, they're kind of there pulling in, they're sourcing data, ingesting raw data, and then making it available to the next layer. So again, that's kind of distributed processing tools. They've got coarse access controls. So really, they just need to get access to all levels, so they're very trusted. And again, we're looking at kind of a lakehouse architecture at this level. So from the kind of bottom level, from the data enablement level, the data is cleaned and processed and then pushed up into the next level. So the data operators and data analyzers are only getting that nice, clean, processed data, which they can just use without actually having to know about kind of where it came from or kind of what format or condition it arrived in. They're getting kind of standardization of the data, and so they can use standard tools to access and process this data. So yeah, on the data operator side, we've got the software engineers and ML engineers, and they're accessing the data through kind of, say, data mesh or data APIs. And typically they're accessing, with programmatic access using kind of IAMs. On the data analyzers side, again, data analysts and business analysts, and so they're usually accessing data through data warehouses or potentially even lake houses as well. And then on the top layer is our data readers. And again, it's kind of split into two, where we've got our external data readers, so kind of customers and clients. And so they're using accessing data through kind of web UIs and applications. And so they've got very fine-grained access to set questions or queries. So, when we, as the data bubbles up, the access requirements should get more fine-grained because the amount of kind of exploration and access to the data should be tightened down. So, as a bank user, I should only be able to access my bank details and not anyone else's. On the other side of the data readers, we've got our internal data readers. And so they're the business decision makers. And so they're using they're getting data via our reporting interfaces. So kind of Tableau and Looker and those sort of interfaces. And again, they've got fine-grained access control to allow limited exploration. So we still want them to be able to create reports and access different data to be able to build reports from. But we've still got to kind of do that on a permissions basis to really cut down on kind of any data leakage. So really, rather than kind of creating these data sheds and data cathedrals, what we need to be creating is kind of data mansions. So all the data or kind of systems are under one roof, but we've still got our definite separation between our different users and our different users' needs. So the ground floor, we've got our data explorers and data enablements with low usability of data and a high maturity of user. The first floor is our data operators and analyzers with a kind of medium usability of data and medium maturity of our users. And then top floor are our data readers. So they're the ones who really need that high usability of data because they are really kind of low mature. They've got a low maturity of kind of knowledge and user. So yeah, so that was quite a quick blast through data sheds, data cathedrals. But yeah, has anyone got any questions? I think you're on mute again.
Oh gosh, I'm all over the shop today. Sorry about that. I was going to say that was an awesome presentation, Matt. We've been experimenting with a few different time slots for the meetup when we meet online. We've been doing lunchtime ones and sometimes evening slots as well. So I think, a few folks must be tucking into some dinner and they've lost their voice or something like that at the minute. But it was interesting, your analogy between sort of data sheds and data cathedrals and sort of, I guess, this meeting in the middle with, data mansions. Data mesh has been talked about quite a lot in the data engineering space for the last probably, 12 to 18 months. How does that tie in, that thought around sort of, data mansions in regards to sort of, I guess, decentralization, or do you feel like, I
think for me, it kind of doesn't really matter. I think the data mesh is kind of, there's quite a few things like under the whole kind of data mesh idea or architecture. And so I think the kind of centralization, either centralizing or having domain specific, kind of domain owned data, doesn't really get affected by this. I think the data mesh kind of fits really well into the operational side of things, for sure. Whether it could kind of work from more analytics side, I don't know. I think that kind of is kind of almost a use case one. But in terms of what thing I like about the data mesh and how I feel it fits in there is the forcing of providing interfaces or APIs between each layers. Because quite often what we get now, especially with data lakes, is just, it was this kind of like, there's the data, jump in and use it. Whereas with data meshes, you're actually saying, okay, if you want to access this data, you can access it through, I don't know, a streaming endpoint, a file endpoint, or maybe a data warehouse endpoint. But it kind of gives that option of abstracting anything about the data away from anyone who wants to use it. And ideally, I kind of see the future is data engineers kind of build less stuff or less features, because software engineers should be taking that over. And I kind of feel our responsibility as data engineers is to kind of make that happen, or make it easier for just a software engineer to turn up and build a cool data product.
Yeah, that's a fascinating, it kind of, it really ties into that sort of Kubernetes kind of sidecar style ecosystem where, you're sort of creating plugins or mechanisms for folks to sort of, plug into and sort of create data products. And I guess, perhaps a little bit like, what Dean was mentioning around sort of, our role as data engineers becomes more around these sort of, the building the ecosystem around the data products and things like that. So it's such an evolving space, this data engineering space. It's really exciting to be a part of. So, really appreciate your time tonight, Matt. I know you're probably busy flying from one client to the next, isn't it?
Yeah, there's a bit of running around, but yeah, I enjoy the work. So yeah, I agree with you. Like, data engineering is a brilliant place to be at the moment. Yeah.
Oh, thanks so much. Apologies, we didn't have a more active set of questions tonight, but no, it's been really good fun having both you and Dean on the line. I know, Ingrid, are you available to give one last plug for DataEng Bytes?
Of course. Let me just. Do you want me to share my screen, or do you have it?
Yeah, if you want it, or if you don't have it open, we can. We don't have to, but
just a reminder, everybody, tickets are available in the DataEng Bytes website, and call for papers submissions is still open until July 2nd. Peter, correct me if I'm wrong.
Yep, that's a Friday, so we may extend it until the Monday. But yeah.
Yeah, so people can spend the weekend thinking about the experience that they had with data this weekend, and maybe put something together and send their submissions, so we can have a mix of. We have a few submissions so far, very interesting ones. So yeah, I think it's going to be great, because we're going to have different perspective in this conference. So again, 26th and 27th of August. So still time to get the tickets.
Awesome. Yep, sounds exciting. At the moment, super early bird tickets are $49 plus GST. So that's a really, really good price. I think the full price is going up to $99. And also, you know, I know there's lots of outbreaks happening and lots of uncertainty in the world at the moment. So, you know, there's a full refund available if we have to cancel the in-person component, or you're not able to attend for any COVID-related reasons. It's just, we definitely hope that we can meet in person. I think it's really good fun. We've had a few in-person meetups.
It will be good to see all the faces again.
Absolutely.
In the conference, yeah.
Well, thanks so much for joining us, Ingrid, tonight and letting us know. And thank you so much for all your efforts organising the conference as well. And big thanks to Dean and Matt for putting a presentation together for us tonight. Thanks so much. And
thank you.
See you next time at the meetup. Cheers. Bye.
Bye.